one revolute joint. The revolute joint is one which can flexibly rotate. Please look here. The revolute joint, in the sense, it will be like this. You can see here. You can see here. The revolute joint, I can rotate this. I can rotate this. This is called revolute joint. The first one is called prismatic joint. And since they have the revolute joint is also there, they can able to do a complex job as compared to the linear one, as compared to the Cartesian coordinate robot. Then what about the application point of view? What is the application of these robots? So whatever the previous robots can able to do, these robots can do. What the previous robot was doing, it was doing pick and place, and it can do the machine loading and unloading. Along with this, additionally, it can do simple painting and welding operations. It can do simple welding and painting operations. You should have to remember how to write this figure. A very simple figure I have given. I have given a very simple figure. Try to remember how to write them up. Okay. Next, let me come to a spherical coordinate system, or spherical or polar coordinate system. The spherical or polar coordinate system will be like this. Very simple figure I will be giving. Please try to remember. If you want, you can write this other one reduced figure I will be giving. You can write that also. Okay, so okay, and it can revolve here, and it can flexibly move in this direction. So this is called as a spherical coordinate robot, and the work volume generated by these robots will be in the form of a segment of a sphere. In the form of a segment of a sphere, you can see here. If I have been given a sphere of this kind, then the work volume generated by these robots will be in this form. You can see here the robot will be having work volume of this kind. Okay, work volume will be like this segment of a sphere, and since it is having rotational here, and it is having rotational here, and it is having linear along this direction, so these robots are called as the spherical because of the work volume generated by this robot will be in the form of a segment of a sphere. Hence the name spherical coordinate system. And these robots will be having the coordinates. They are having coordinates r, theta, phi. Okay, it is linear, rotational, and rotational. Or simply we can say these robots also will be represented by 1L and 2R, or simply we can say LRR robots. These are called LRR robots. And these robots have, please look here, in the previous case, in the cylindrical coordinate system, at least one below the other, they are having similar structure. If they are not having the similar structure in this direction, but uniformly along the vertical direction, each will be having the similar kind of repeatability and accuracy. But in case of the spherical, you can see the spherical coordinate doesn't have the proper accuracy and repeatability throughout the work volume. Okay, throughout the work volume, it is not having a good resolution. The spatial resoluted work volume of the robot is not uniform throughout the work volume, so that they require little more sophisticated controller as compared to the spherical, cylindrical, and the Cartesian coordinate robot. And where all we can use them, please look here. Wherever the rotational joint will be increased, the flexibility will be increased. Wherever the rotational will be R will be increased, the flexibility will be increased. So it is having very good flexibility, only one linear. So definitely it can be used for the earlier one, pick and place, machine loading and unloading. Along with this, it can able to earlier I had given a simple welding. Now we can say simply welding and painting operations. Welding, painting, along with this simple assembly. Simple assembly operations it can be used. So this is about the spherical coordinate robot. Now let me go to the other one, the SCARA. The SCARA or articulated robot. Articulated robot or SCARA. It is called selective compliance assembly robotic arm. SCARA, S-C-A-R-A. It is called SCARA robot. And how it appears? Actually, basically, these articulated robot have the the two type. One is vertical SCARA and another one is a horizontal SCARA. Okay, vertical SCARA and horizontal SCARA. We can see them. And the SCARA, how it will be appearing? You can see here the horizontal SCARA will be like this. Okay, and the vertical, this is horizontal SCARA. It will be fixed here to the wall, and vertical SCARA is like this. Okay, you can otherwise, and these two, instead of writing them, I will be giving you a very realistic figure. You can see here. See, look here, and this is also rotational, and this is also rotational, and this is also rotational. That's all. It is a SCARA robot. And now let me look into the explanation. What we have to do. The explanation. These robots are quite resembles to the human arm, so that they are called articulated robot. They are called articulated robot. And about the work volume, it is not having definite work volume. Definite work volume is not there. The work volume traced by these robots will not be definite. It will not be definite. So we are not going to show the work volume of these robots. And another one, the next one, these are also called RRR robots, or simply we can say 3 are robots. And the next one, the work volume generated by these robots will be very, very complicated. Definitely the sparsely regenerated work volume will not be uniform. They require a sophisticated controller as compared to the spherical, cylindrical and the Cartesian coordinate robots. And these robots applications, you can write whatever you are going to write, those are all applications. And you can write a pick and place to the complex assembly operation. Pick and place to complex assembly operation. It can able to do. So this is about the